Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. If you can recollect and remember, in the previous class we had discussed about a job or a program and processes in a greater detail. Moving ahead, in today's class we will try to create basic distinction between a program and a process, and then we will try to discuss the various attributes of a process. Now let us begin by differentiating program and a process. Now, as we know, a program basically refers to a set of instructions with associated data residing on the secondary memory, which, if required, is to be brought to main memory and it's to be prepared for execution. So, a program or a job is an inactive element that is residing on the storage devices, which, if required to be executed, is to be brought onto the main memory, and then CPU has to be allotted to the same for realizing a set of well-defined objectives. We have also learned in the previous class that a program can be instantiated into various instances that are capable of performing different operations. So, for an example, a program for finding factorial of a number can be used in order to find factorial of different numbers. So, a program can be instantiated into various instances in order to perform operation. Now, we have also learned that programs or jobs are basically of two types, which are CPU bound job or program or IO bound job or program. So the basic distinction between these two has also been discussed in the previous class, where IO bound jobs are jobs with a smaller CPU time and a longer IO time, whereas CPU bound jobs are jobs with longer CPU cycle and shorter IO times. So we have also understood it with the help of an example. So, in brief, a program is an inactive element that refers to a set of instructions and associated data residing on the storage devices, which is to be brought to the main memory if it is required to be executed in order to exhibit a desired behavior. Now, likewise, a process is a program on execution. Again, I'll repeat it. A process is a program on execution. So whenever a program is allotted CPU time for exhibiting desired behavior, then that program or instance of the program is called as a process. So a program by itself is not a process. A program on execution is known as a process. Now, as discussed, a program is a passive entity, whereas a process is an active entity. Likewise, resources are not assigned to the program, but resources are assigned to the processes. So for an example, CPU time, it's not assigned to the program, but it's assigned to the processes. Whereas a set of associated resources may be shared among several processes through a scheduling algorithm. Say for an example, in a computer system. So if for an example, if it has a unicore, so if there is only one processor, then that processor has to be shared amidst various processes. So there has to be a well-defined protocol or mechanism for coordinating execution of various processes. Now that is called as a scheduling algorithm. So wherein the processes are sharing resources, there has to be a very efficient scheduling algorithm that is capable of coordinating the operations of various processes. So this is the basic distinction between program and a process. Now let us move on to the next important element that describes all the processes or a process, that is called as PCB. Now PCB basically stands for process control block. Again, I'll repeat it. PCB stands for process control block. So a process control block is a data structure that is maintained by the operating system with each and every process that stores the process state information. Again, I'll repeat it. A program or process control block is a data structure that's associated with a process by the operating system that keeps track of all the process states. Now, each and every process control block is identified by an integer process ID that's called as PID. So each and every process control block is identified by integer identification that is called as PID. Now, the process control block is maintained for a process throughout its lifetime and it's deleted once the process terminates. So as we have learned earlier as well, whenever a process gets terminated, the state information of the process is lost. So process control block is the state information of the process. So again, I'll repeat it. So process control block is a data structure that is maintained by the operating system on behalf of each and every process that stores the process state information. The process control block is identified by integer ID that is called as a PID. Likewise, process control block is maintained for a process throughout its lifetime and it's deleted once the process terminates or is considered to be zombie process. Now let us try to know what are the elements of process control block. Now the first information that process control block stores is the process state. Now this is very much important. Then the process primitives followed by process ID, then pointer, program counter, CPU registers, CPU scheduling information, then memory management information, then accounting information, likewise IO status information. So these are the various information that is being stored or the PCB has in it. So it has process state, it has process privileges, it has process ID, it has pointer, it has program counter, it has CPU registers, it has CPU scheduling information, memory management information, accounting information, and IO status information. Now let us try to understand what all these set of attributes represent. Now let us try to understand PCB in a greater detail. So as said, a PCB keeps all the information needed to keep track of a process as listed below in the table. So it keeps track of all possible informations pertaining to a process. Now the first one is called as a process state. Now process state basically refers to the current state of the process. Again, I'll repeat it. The process state refers to the current state of the process. The current state of the process may be either new, or it may be either ready, it may be either running, or it may be in a waiting state, or eventually it may also be in terminated state. So process state basically keeps track of the state of the process, whether it is in ready state or running state, waiting state or terminated state. Now, in addition to that, it also keeps track of process status word, main memory, resource information, and process priority. So, these are the additional information that process state basically tries to address to. Again, I'll repeat it. Process status word, main memory requirement, resource information, resource required information, and then process priority. Now, the next information that PCB maintains is process privileges. So this is required in order to allow or disallow access to system resources. So this is very important primitives that are associated with processes which decides whether to allow or disallow access to system resources. Now next one is process ID. Process ID is a unique identification number that is associated with each and every process by the operating system. Now this process ID is associated with the process in order to enable proper monitoring of the process. So in order to monitor the process efficiently, what do we require is we require a process ID. Now the next important attribute that is there in PCB is the pointer. So a pointer that points to the parent process of a given process. So this is very much important. So a pointer that points to the parent process. So it will keep track of the process hierarchy. So it will help in enhancing monitoring and traceability. Now next one is program counter. Now program counter is a pointer to the address of the next instruction that is to be executed for this process. So program counter, as we all know, is a register that keeps track of what is the instruction that is to be executed next in a process. Now the next element of PCB is the CPU registers. So CPU registers are storage devices that are capable of storing data and instructions that are required by the processor or the central processing unit. We have learned in the previous class that it is only the CPU register that the processor interacts with in order to perform operations. So various CPU registers where process needs to be stored for execution for running state. So this is what is CPU register. So CPU registers are memory devices that are capable of storing instructions and data pertaining to a process whenever the process is to be executed by the central processing unit. And we have also learned that the central processing unit is only in contact with the registers whenever it's performing operations. So rest of the memory devices are in place in order to assist the CPU registers. Now next one is CPU scheduling information. So scheduling information basically refers to attributes like how many processes are there, what is the arrival time, what is the execution time, what is the associated priority with each and every processes, whether it's preemptive or non-preemptive scheduling algorithm. So various process information that is associated with the scheduling is also maintained in a process control block. Now next one is memory management information. This includes the information about the page table, memory limits, segments, depending upon memory used by the operating system. So it keeps track of all the memory information or information pertaining to the usage of the memory. Now next one is the accounting information. So accounting information basically includes CPU time used, turnaround time, main memory requirement, secondary storage requirement, system programs requirement or use, number and types of I/O operations, time limit for I/O operations, number of input records read, number of output records written. So all the information pertaining to the process is being maintained in the process control block, right? Again I'll repeat it. So elements like CPU time required, turnaround time required, main memory requirement, secondary storage memory requirement, then system programs requirement, then number and types of I/O operations, time spent for I/O operations, number of input records read, number of outputs record written. So all of these information is also maintained for a process in a process control block. Now next one is I/O state information or I/O status information. So this includes a list of I/O devices that are allotted to the process whenever the process is performing operation. So here we have learned that in a process control block, various types of information are maintained or various types of information is maintained, which includes process state, process privileges, process ID, pointer, program counter, CPU registers, CPU scheduling information, main memory management, accounting information, and I/O status information. So these are the contents of the process control block. Now, till now, what we have learned in today's class is we have learned about the basic distinction between program and a process, where we have learned that a program is an inactive element whereas a process is an active element, but both refers to a set of instructions with associated data that is executed to perform desired behavior. But just the mode of the elements decides whether it's a program or a process. Now we have also learned that resources are assigned not to the program but to the processes. So when the processes are being executed by the by a computer system, so we need to ensure that a suitable scheduling algorithm is in place that are capable of coordinating the actions of various processes. Now likewise, then we discussed the process control block, where we learned about what is process control block, and why is it important, and what are the types of informations that are maintained in process control block, where we learned about that process control block keeps track of process state, process privileges, process ID, pointer, program counter, then CPU register, CPU scheduling information, memory management information, accounting information, and eventually IO status information. Now, let us try to move on to a very important aspect of operating system, that is called as scheduling. Now, let us try to understand what is scheduling. As we have learned in brief in the previous class as well, when there exist multiple processes in a computer system, there has to be an efficient mechanism of coordinating actions of these processes in the computer system, and this mechanism is referred to as scheduling. So, the process scheduling is a fundamental and essential part of multi-programming in an operating system. So, when there are multiple programs in an operating system, there has to be an efficient mechanism for coordinating execution of various processes, and this mechanism is referred to as process scheduling. So, when multiple programs are competing for CPU time at the same time and waiting for execution, in such situation, the decision for selecting an appropriate process for execution is called as scheduling. Again, I repeat it. When multiple programs are competing for CPU time at the same time and waiting for execution, in such situation, the decision for selecting an appropriate process for execution is called as scheduling. Now, it is to be understood that the decision for selecting an appropriate process depends on the algorithm pursued by the computer system for scheduling. Say, for an example, a computer system may adhere to first come, first served, or a computer system may adhere to shortest job first, or a computer system may adhere to priority scheduling, or a computer system may adhere to round robin based scheduling. So these are some of the notable examples of scheduling algorithm. So the decision for selecting appropriate process basically depends on the scheduling algorithm that is pursued by the operating system that controls the operations of the computer system. Now, who makes the decision in order to schedule? So, the part of the operating system that chooses the process that is to be executed is called as a scheduler. So, scheduler is a program that is capable of scheduling various processes for execution. Again, I repeat it, scheduler is a program in the operating system that is responsible for scheduling all the processes in the computer system. Now, it allows multiple processes to be loaded into the executable memory, that is the main memory, at any given time, and then the loaded process shares the CPU time using time multiplexing. So, here what we do is we load various processes that are to be executed onto the main memory, and then optimally schedule these processes in order to perform various operations based on time multiplexing or time sharing mechanism. So this is what scheduling is all about. In the next class, we will learn about scheduling in a greater detail, where we will learn about what are the different types of scheduling techniques that are there that can be used in order to schedule processes, and what are different types of schedulers. So first we'll move on to different types of schedulers, and then we'll move on to various scheduling techniques. So in today's class, we had started with distinction between program and a process. Then we moved on to description of the process control block, where we discussed about various elements of the process control block. We discussed the constituent elements in detail, and then eventually we moved on to a brief about scheduling, where we learned about when there exist multiple processes in a computer system, there has to be efficient mechanism for coordinating execution of these processes. So this the process of coordinating execution of different processes is called as scheduling, where we have also learned that there are different types of schedulers. So in the subsequent class, we'll be learning about these schedulers in greater detail. Thank you very much. Have a very nice day.